Bitcoin as digital cash. Welcome to another episode of Understanding the Potential of Bitcoin according to Dr. Saifedean Ammous. We are talking about this book, The Bitcoin Standard, the Decentralized Alternative to Central Banking. It's written by an economics professor from Lebanon. My name is Nikolai and I have been very fascinated with these concepts in the book. And this is a very special episode because we are actually finally talking about Bitcoin, about digital money. Up to this point, we've just laid the foundations. We've talked about the history of money. We talked about understanding money in general, like how does it work and what makes money money, how is it used, what was different usages in the past, how did different technological advancement change how we used our media of exchange. All of these kind of questions we addressed in the episodes before, and now we actually finally talk about Bitcoin. So you can be full of excitement as I am. He talks about the question of technological advancement throughout the history of humanity and how it's always connected to different forms of media of exchange. The biggest one was the introduction of metal production, metallurgy, and that produced different solutions to the problem of money. And so he says, well, basically, every step of the way, technological advances and realities shaped the monetary standards that people employed. And this is actually what happened with Bitcoin as well, that Bitcoin is a new technological solution to the money problem. So it's always connected to technology, and this will be very important. How do we understand Bitcoin in a very simple way? And I think he does it brilliantly in comparing it to the two forms of payment methods that we know currently. So there is the payment method of cash that we all know. You go to the bakery and you want to buy something, you give them a dollar bill and you pay for it. And that has huge advantages because it's an immediate and final settlement of payment between two parties. So it's final, you don't need anything else, and there's no trust required between you and the guy at the bakery. You just hand them the money and that's it. There is no third party needed. It's just the two of you. You exchange that bill and then it's done. But the big problem is you have to, of course, be physically present at the same place at the same time, both parties of the deal. Otherwise, you can't really use cash. So we use cash, but then you have the physical presence problem, and therefore we invented something else, which is intermediated payments. If you cannot be there physically present with the person that you want to pay, you need a different kind of payment, and that would be something like a check, something like credit cards, like debit cards, bank wire transfers, money transfer services, and of course everything connected digitally that we're currently using, like PayPal and all of these services, is basically trying to help us do payments when we're not able to be physically present at the same time as the party we do the deal with. So that is very convenient, but of course there is a big drawback on that option, and that is that you always have to trust in that third party, that intermediary person. You cannot know for sure what's going on. You have to trust the person that intermediates the payment, that everything is going to work out fine, and that's of course a big drawback. And you don't have immediate and final settlement between the two parties because it takes some time until the payment is completed and cleared. So that can take minutes or up to hours, and of course it also costs something. You need to pay the intermediary party so that they do the deal for you. Everybody who has some kind of online business knows about that. Bitcoin solves that problem. So how do they do it? Well, basically Bitcoin combines the two in a way that you had before the invention of Bitcoin. You had intermediate payments. They included all forms of digital payment. So digital payment was only possible in a intermediated way. Why? Because the nature of digital objects since the inception of computers is that they are not scarce. So basically when you send something digitally, you actually don't send something, you just copy it. So everything digitally had to be intermediated until now, because you can reproduce digital objects endlessly, and therefore you can have double spending or triple spending, because you could just say, well, I'm sending you this, but at the same time I'm sending other people. So you could never do digital payments without an intermediary. And basically the problem is that because of that digital nature of things, you had no way of guaranteeing that the payer was being honest with his funds and not using them more than once. That was until the invention of Bitcoin. So basically, you had to have a third party overseeing your account, and they had to be able to verify the integrity of the payments carried out. All digital forms of payments had to be supervised by a third party. And now comes in Bitcoin, and they basically found, after years and years of searching and developing, they found a solution for how to have digital cash, which was a contradiction beforehand. Either you had something digital and then you could do payments without being present at the same time, but then you needed an intermediary, or you had cash, and if you had cash, you could do it without trust, you could do it immediate, final, but you had to be physically present. The two were never combined, they were two separate forms of payment. And of course, as a human being, you want the best of both worlds. You want the you want the immediacy and the finality of a cash transaction. You want the trustless transaction, but you also want to have a transaction possible without being there physically. So Bitcoin combines the two. And how did that work? Well, they were researching that problem for decades. The cypherpunk movement started in the 80s, in the 90s. So before Bitcoin came, there was a lot of research going on, and they tried a lot of different things, Hashcash and whatever. But they never really solved it until 2009, when Satoshi Nakamoto, which is a pseudonym, so we don't really know who invented Bitcoin, we just know that this person under that name published a white paper, and in the white paper this person explained a system of how you could have actually digital cash. And it's a form of code. It's basically an open source software that this person put out and explained. I will not in this video explain the technical aspects of Bitcoin, how it works, because right now we're in the monetary features of Bitcoin, but that will come in a later video. So what they did is they found an engineering solution that allowed for digital payments without having to rely on a trusted third-party intermediary. That would, of course, only be possible if they solved the problem of double spending. So how did they do that? Well, first they needed to make, if you want to solve the double spending problem, you need to make it scarce, because that's the problem with everything digital, that it is abundant. You can always copy and copy and copy. So if you want to have a store of value, as we learned in videos before, it needs to be scarce. How did they do that? Well, first of all, we need to understand again what are the big drawbacks and problems about having digital payments through an intermediary, or in general payments with like a bank in between or whatever. So we understand why they were so eager to find something like cash, but in a much more scalable way. The problem with third parties is that is always an added security weakness. You have another point of failure. It's not up to you and the party that you do the deal with, it's also up to that third party that everything goes well. And therefore you have added security weakness, you have new possibilities for theft, hacking, all of that. And of course you have technical failures, right? All of this you don't have with cash. Then of course another second problem with intermediaries is that it leaves the parties vulnerable to surveillance and bans by political authorities, because every intermediary can possibly be banned or confiscated, or they're surveilled by governments or other agencies, and that would mean that they stop the payment under the pretext of security, terrorism, money laundering, whatever. So you're not actually sovereign in how you handle your money. And of course, the third big reason is the risk of fraud. You have to trust that third party that everything goes well. And of course, the more you want to trust them, the bigger you're going to have transaction costs, and that delays the final settlement of payment. So all of these questions then led to how can we deal with these shortcomings, and how can we how is Satoshi Nakamoto's invention of Bitcoin addressing these things? Basically, in his white paper, he says his motivation for Bitcoin is to create a purely peer-to-peer, so person-to-person, party-to-party form of electronic cash. So he wants to combine the two, and that is his big proposal, and it actually worked. How does he do it? Well, it doesn't require trust, and its supply cannot be altered. There cannot be produced more of, other than what is written in the code. So Bitcoin brings the desirable features of physical cash, which is lack of intermediaries and finality of transaction, to the digital realm, and combines them with an ironclad monetary policy that cannot be manipulated. And how did they do that? Because we said in the beginning, it's always about technological advances when you have new forms of money. Well, they did it by utilizing three very distinct but important technology. That was the genius of Satoshi Nakamoto, that he combined different technologies that were around beforehand, but not in that combination. And that is, first of all, a distributed peer-to-peer network with no single point of failure. That is the ledger. Then you have hashing, digital signatures, and proof of work. So those four. I will explain what they all mean, but that is so important. If you want to understand Bitcoin, you need to understand these technological advances. Distributed peer-to-peer network, hashing, digital signatures, and proof of work. The foundation for how Bitcoin works is a system of proof and verification, because that's what you need. If you don't have a third party, you need to trust that what you have been given is actually finally yours and not still the sender's, and that needs to go about through verification. So every transaction has to be recorded by every member of the network so that they all share one common ledger of balances and transactions. That is the idea, that no single party controls it, but every single person of the network. So the Bitcoin network, every single person who wants to be a part of it can download the whole ledger. You are then a node, and as a node, you can yourself verify every single transaction if the person who sent that money actually had that money, and if it actually, after sending it, was subtracted from their account. So it's basically the whole network that is involved in that verification process. All network members can verify the sender had a sufficient balance, and nodes then compete to be the first to update the ledger with a new block of transactions every 10 minutes. That is the proof of work concept. So what happens is, you basically have a blockchain underlying the whole system, which means every 10 minutes, all the transactions that are transmitted into the network are summarized into a block. And now every node that wants to can say, well, I'm the first one who will give that new block of transactions into the network, but not so fast. You first need to solve a so-called proof of work, how mathematical problem in order to be allowed to send that block to the network. So that mathematical problem that you need to solve has nothing to do with the functionality of the code itself. It's basically just a way of securing that you put in work in order to generate that block. Because that would mean that everyone who gives a block to the network has expended energy, because there's no other way of solving the mathematical problems. That is what you need all the energy for. The computers running all those different calculations until they find the solution to this mathematical problem. And that means that the production of new Bitcoin is actually connected to the use of energy, and therefore it is costly. That is why this process is called mining. They have very well understood that in order for something to be valuable, it needs to be very hard to produce it. Otherwise, it won't be used as a store of value, because you can easily produce more of it. And that is how Satoshi Nakamoto came up with this idea, that you basically need to expend energy in order to transmit that block into the network. And then, of course, game theory, you need the miner who does that, who solves that problem, which can be everyone, but of course right now you need huge computers to do that work. So it's an industrial complex that is starting there. But of course they need to be incentivized to do that. And how does that work? Well, they get a certain number of Bitcoin for every block they transmit. So basically they are allowed, that is called the Coinbase, they are allowed to write in the first transaction of the block a certain number of Bitcoin that they get themselves. And that number of Bitcoin is currently, I think, 6.5 Bitcoin for every block. So every 10 minutes, a miner gets 6.5 Bitcoin. And those Bitcoins are created out of thin air. They haven't been there before. And we will soon talk about the general supply, because it's limited only 21 million. And so they get that so-called block reward. And of course, they also get the transaction fees that are connected with every transaction that has been transmitted into the network. They get all the transaction fees. So that process is called mining. But if we say, well, there's 21 million Bitcoin and you have all these different miners competing for submitting the next block to the network, well, then the faster they can produce these blocks by expending more energy, and therefore solving the mathematical problems faster, well, then you have more production of Bitcoin, which would mean inflation, right? So how do they solve that problem? And that is actually very ingenious. They did think about that, luckily. The quantity of Bitcoins is pre-programmed and cannot be altered, no matter how much effort and energy is expended on the proof of work. Why? This is achieved through a process called difficulty adjustments. That means that the more people want to buy Bitcoin, the higher the price, and therefore the more miners want to get into the business, because they can get more money for submitting a block to the network. But if you have a rising of the energy expended to solve the mathematical problems, you need to then change the difficulty of the mathematical problem that those computers need to solve, in order for every block, in order that only about every 10 minutes a new block gets solved. Do you understand? So you want that process to keep on going, that every 10 minutes there is a new block, roughly. Therefore, you need to calculate, or you need to change the difficulty of the mathematical problems that the miners need to solve. So if there's a lot of miners, you have a high difficulty. If you have very few miners, the difficulty lowers. And therefore, that's how you can also see that we're in a bear market or in a bull market, if you look at the rate of the difficulty. And that is actually very easy to do because if you look at it from a mathematical point, it's basically they need to produce a hash. A hash is basically just you put a set of data into a mathematical formula, and that formula transforms that data into a fixed set of hash. So a fixed set of cryptographically encrypted. So then it's just it says 210 LMFG whatever, and there's like I don't know, dozens of digits, and you can, if you have that formula, you can know the data set that was inputted, but you cannot know from the hash itself what data was inputted. You need a so-called private key in order to decrypt that hash. So what they do is, in proof of work difficulty adjustments, they say, well, you need to find a hash which starts with 4 zeros in the beginning, and then those computer calculate. And if you just want to higher the difficulty, you say you need to find a hash with 5 zeros in the beginning, and then it's exponentially harder. So no problem to do that. Therefore, Bitcoin is the hardest money ever invented through these different technological ideas. The difficulty adjustment makes Bitcoin actually harder than gold, because it means that in gold you still can hire the mining effort if there's a lot of demand for gold. But in Bitcoin, it means you can, no matter how high the mining effort, you will never be able to produce more Bitcoin, because that is written in the code how much Bitcoin you will get. And basically the idea is you get, in the beginning it was 50 Bitcoin per block, and then you have a so-called halvening every about 4 years. The block rewards halvens, because overall you have only 21 million Bitcoin, and that means every 4 years the block rewards is less. So then it was 25 and then it was 12.5 in 2016, and now I think we're at 12.5 right now. I said 6.5 earlier, and now we will go next year in May. There will be another halvening, which will change. I'm pretty sure it will change the price of Bitcoin dramatically, because it will become a lot more scarce. It will be as scarce about as gold, and so on until 2140. All Bitcoin will be mined, and then the block reward will just be transaction fees. But because it's always happening, 20 million coins of the 21 million coins will be mined already by 2025. So in 5 more years, or 6 more years, all 20 million will be mined already. So yeah. The cool thing about this process of the miners solving these problems is the asymmetry between the cost of solving the proof of work necessary to commit a transaction to the ledger and the cost of verifying its validity. So it's very, very easy to verify it, but it's very costly to commit a transaction to the ledger for the miner. And therefore, because the miners or the nodes committing a block to the network, they have so much energy that they spend, they are therefore incentivized not to deliberately waste resources by being fraudulent or cheating. So that is the idea. If you have expended all that energy for producing that block, of course you will not simply say, well, I'm going to add a false transaction into that block, because then that block will be rejected by the community, because they can themselves check the whole ledger, and you as a miner have wasted all that energy. So it becomes increasingly difficult to alter the record as the energy needed is larger than the energy already expended. So you have a system of 100% verification and 0% trust, because every node in the whole network can look at the ledger. You have great ownership by a public address. It's not, you own the Bitcoin not through your name, but through a public address, which is again a hash that can be easily produced. You can just do it wherever you want to online. You can produce a public address. It's like an email address. And then you need a private key in order to sign that public address. That's kind of like a password for your email account. So you can easily send money to that public address. You just need that address, like an email address, but you cannot easily, you can only send money from that public address or withdraw money from that public address if you have the password, the private key. You have the great opportunity with Bitcoin that it is highly saleable across scales, because you have 21 million, but each Bitcoin is dividable by is 100 million Satoshis. Satoshi is the smaller unit, so you have a great divisibility. And of course, you also have a great salability across space, because it is not like cash, you need to carry it around, or like gold, you actually need to buy huge ships and protect it. You can just do it digitally because it's a digital ledger. So basically, Bitcoin relies on economic incentives, making fraud far costlier than its rewards. And that's the whole idea behind it, that you have this game theory thinking that everybody who is part of the network needs to be incentivized economically, otherwise it won't work in the long run. The basic idea why this is so revolutionary is because you never beforehand had digital scarcity. That was a contradiction in itself. And that's the invention that Nakamoto came up with by combining these 4 different technologies. And that is the first example of a digital good that is scarce and cannot be reproduced infinitively. And that, of course, it has been tried for the last 10 years to somehow get around it, but it's very, very hard, because you have that distributed ledger across thousands and thousands of nodes, and you would need to change every single one in order to change the protocol and the transaction history. So how I explained some of the things about the supply. Well, what is interesting about the supply of 21 million is that you have that fixed inflation schedule, basically knowing it beforehand, in comparison to something that the government can just decide in the next central bank meeting how much they want to inflate the price. You actually know through the halvenings about every 4 years what is going to be the supply schedule. And that means that you're going to have an annual growth rate of about 2.61% next year, 2020. And that is about the supply growth rate of gold. The great thing is that this is going to drop even further. In the next year, it's going to be 1.77%. And then by 2025, it's going to be less than 1%. And that's never, ever been there in the history of humanity. A good that is that hard to produce and has that little growth rate, because usually if you have something that is very valuable, you're going to have a lot of people who want to produce more of, and that is what Satoshi Nakamoto thought about, how you can actually prevent that from happening in Bitcoin. And I will do another video about all the other cryptocurrencies, because that is one of the biggest differences between Bitcoin and all the others, that you cannot change how much you're going to have of it. And I would say almost all other cryptocurrencies, there are ways to do it. So the last thing I want to talk about is basically the success story of Bitcoin. You have this thing being invented in 2009, and now about 10 years later, it has grown 422,520%. That's an annual compound growth rate of 573% per year. Right now it's about 100 billion market value, which is a lot for something in just 10 years. That is a success story that's never been there. And in the beginning, it wasn't even sure if it would be adopted as a medium of exchange, which is a free market decision, right? But then you had the first online exchange named New Liberty Standard in October 2009. They sold Bitcoin at a price of less than 1/10 of a cent. So not even a cent, not even a penny for one Bitcoin. And then you had in May 2010, somebody bought 2 pizzas worth of $25 for 10,000 Bitcoins. And that would mean the price of a Bitcoin was in 2010 $0.0025 dollars, so less than a penny. And then it just grew and grew and grew, and now the purchasing power of the currency is enormous, and you have a lot of transactions. You have daily transactions, hundreds of thousands, and of course that's a big question. How is that scalable, the transactions? Because one block can be maximally like a megabyte, so you're going to have 500,000 transaction maximum a day, which is very, very little. But it's no problem because you can build second layer solutions to it, and the Bitcoin will be basically the final settlement layer, like the settlement between big banks. You don't have, like, when you buy something with your debit card, it's not like the bank is going to immediately finalize that settlement, but they're going to do it in the end when they have all the different transactions of the day or maybe of the week. They're going to settle it with the banks of the people who paid you or that you gave the money to. And all that thing in between, all those different transactions in between, they can just do that on their own ledger. And that's the idea of maybe Lightning Network, but we will talk about that later. So well, that is basically it. There is some more interesting data, but I think the main ideas have been made clear. I hope so, at least. And I hope you enjoy this video, and I would be very thankful for if you want to share it, and we get some more people into discussion. Bitcoin is very, very fascinating if you understand the technology behind it and if you understand why it's unique in the history of the development of different monetary assets. And I think it has a huge potential. Alrighty, have a good day.